Okay guys, let's have a look at 11 then. We've got y equals x to the 4 minus 3x squared. So let's get the gradient function then, dy dx. Differentiate, we get 4x cubed minus, and it's going to be 6, isn't it, x to the power 1. Let that equal 0. Now if you look along this row, we can take out what's common and try and factorise it, can't we? There's a 2 common, agreed, all the way along. And also there's an x common, so outside the bracket we can put 2x. It just remains to find out what two things we need to put in here and here. So 2x times what gives 4x cubed? We need a 2. And then you'll need an x squared, won't you? That will make the 4x cubed, won't it? Yeah? You'll need a minus. 2 times something gives 6 will be 3. And then the x is fine, because it's just an x, so that's fine. So it's just 3, isn't it? Okay, good. Yeah? Everything alright? So that equals 0. So when does that equal 0? Well, that product equals 0, and that can happen when either this is 0, or it can happen when this is 0, isn't it? So the first thing to say is that this product is 0 when 2x equals 0, and that tells you that x is 0. There we are. There's our first turning point, when dy dx is 0. Put 0 in here, you get 0 minus 0, which is 0. Yeah, it's fine. And then the next one, well, when does 2x squared minus 3 equal 0? Move the 3 across, 2x squared equals 3. And then divide by 2 both sides, x squared equals 2/3. To undo a square, you square root. We've done that before, so I'll just put it down. Square root of 2/3 plus or minus. So we better get the decimal, haven't we? So what does x equal then? Plus or minus square root 2/3. So we need the square root of bracket. Oh, we can just put the fraction, can't we, like that? That's easy. 2/3. That's fine. Move up to ground level, which is nice. Square root 2/3. Get the decimal. 0.82 to 2 dp here. So that's 0.82, and it was a plus or a minus. There we go. So there's our 3 values then for our turning points. Now we better work out whether they're max or mins and the input output. So input is 0. When x equals 0, what does y equal? Go back up here, put 0 in. Minus 3 times 0. 0 to the 4 is 0. 0 squared is 0. 3 times 0 is 0. So that's 0. This is 0. 0 take 0 is 0. So when x is 0, y is 0. Yeah? And then the other ones. So when x equals 0.82, say, what does y equal? Well, I'll put it up. I'll give myself a bit more room, sorry, because I think I need it. So when x equals 0.82, now y will equal, well, you've got x to the 4, yeah, put a bracket around that, minus 3 times that squared, x squared, yeah. Now our x input value is 0.82, so let's just put that in here instead of x, and here let's write that in. So it's 0.82 and 0.82, yeah. Get our calculator. So it's 0.82 to the power 4, which I can just write as 0.82 power 4 ground level. Yeah, power 4 minus 3 times. And then it was 0.82, wasn't it? Squared. 0.82 power squared. There we are. Equals minus 1.57. So equals minus 1.57. Oops. Oh, bother. Better do that again then, hadn't I? 0.82. But I'm going to use a little bracket because I'll need that next time. 0.82 bracket power 4 minus 3 times bracket 0.82 bracket squared. I managed to do that wrong as well now, haven't I? Rushing like that. Get down to ground level. Minus 3 times bracket 0.82 squared. Yeah? Equals minus 1.56 as we said, but it rounds up to 57. So we got that here. I'll put it in here. Minus 1.57. Now the other value we've got to get, which I'll do up here, just to finish off on this page, x equals minus 0.82, wasn't it? What does y equal then? Let's go back to our calculator, and what we can do is we can toggle back. And every time we see the input value, like here's the first time it occurs, put a minus, and then go forward and put the minus there. And that's the only two times it appears, isn't it? The x's appear. So press equals, we get minus 1.57. Yeah, which is what we would have expected. Minus 1.57. Okay? So there's our input output. So let's do that on a sketch. Mark them off, because that's the first thing we've done. So here's our equation. Here's our axes. Agreed. Here's our 0. Here's our input line. Here's our output line. Now what have we got? We've got x is 0, input is 0, output is 0. So there we go, mark that off. Input is 0.82, which we can say is here. And when the output there was minus 1.57. Yes, I'll put that there. Minus 1.57. So there's the output. And then the input was minus 0.82, wasn't it? Yep, minus 0.82. And again, the output here was down there. So that's what we've got. We don't know at the moment whether they're max or mins. We're not sure, so I'll put in the two possibilities. So let's work out d2y by dx squared then, shall we? We know that dy dx, so I'll quickly put it on this page as well, is 4x cubed minus 6x, isn't it? So d2y will be 12x squared minus 6, won't it? So what have we got then? So we got 12x squared minus 6. Now, x squared, 0.82. If I put 0.82 in here, 0.82 squared, it'll be 12 times 0.82 squared minus 6. And that occurs when x equals 0.82, wasn't it? And it'll be the same value when x is minus 0.82, won't it? Because if you square, it's that squared. So you'll get the same calculation, same number, different calculation, same number. So let's just tap it in the calculator. Let's tap this one in the calculator. They're identical in results. So it'll be 12 times 0.82 squared. Got a feeling it's going to be a bit of a pain. Equals. Oh, good. Yeah, 12 times 0.82 squared minus 6 is 2. 2.06, so it's positive is what we're worried about. So this is positive. So if it's positive, it's a min. Same goes here, you'll get the same answer. It's positive, so it's a min. So sorry about the mess on the sketch again. I've managed to do that, haven't I? But let's just say what they are. So that one was a min. This one's a min. Yeah? And then, what was it at 0? Let's do 0. So if we put 0 in here, so I should have put that in as well. So I'll put another little brace here. I should have put it in. If I put 0 in, I'll get minus 6. At x equals 0. And that's negative, so max. Yeah? So that one's a max. So we can get rid of this side. And manage to get rid of everything else as well. Okay, so good. So I better draw that in as best I can. Whoops. So we had a maximum here, didn't we? There we are. Yeah, so we can draw a curve. So it swings down, it doesn't turn anywhere else, it's going to turn here. And then come back up and turn here, go back down and turn here, and then go back up again. A bit like a... Whoops! That shouldn't happen, should it? I'm not going to get rid of it because the whole line will go. But you can see what happens, that shoots up there as well. There we are. Alright then, a bit like a tooth. Alright, that's that one done then. Let's just check the actual sketch. on one of the free sketches you can get hold of. So let's tap in our function. So let's see what we get. Shall we? Just to confirm it. X to the 4, x to the power 4 minus 3 times x squared. There we go. Hey, there we are. Oh, it shoots up quite steep, doesn't it? It's high powers, isn't it? So if you just change the range, of course, let's do minus 3 to 3. Okay. Because that might produce a better graph. And we could change the y-axis as well to make it look even better. But that's fine. Happy with that. Good. So that's that one done then. 11 done. Let's go on to the next one. Good.